we're looking at geometric probability. Now, let's just remember what probability is. It's the number of favorable outcomes over the total number of possible outcomes. So, if you toss a coin 3 times, it's either what or what the first time? Heads or tails. The second time, it's either heads or tails. And the third time, it's either, wow, so many possibilities. Okay, so it could be heads, 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 tails, heads, tails, heads. That just looks bad. Try that again. Heads, tails, heads, heads, tails, tails. I keep doing a T when I should be doing an H. Tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. All right. So it says, what's the probability the coin will land tails up exactly twice? Exactly twice, tails up. Is this tails up exactly twice? This one? No. This one? This one? Yes. This one? No. This one? Yes. This one? This one? No. So it would be 3 out of the 8. Probability, number of outcomes you're looking for out of the total number. When it deals with geometric probability, we're looking for like a certain length. Okay. So what's a probability that if you throw a dart and you hit it on the line somewhere, that'll be between B and C? Well, if these are each 1 unit long, how long's BC? 1. How long's the whole thing? 3. So you got a 1 out of 3 chance of hitting it right on BC. Okay, that's kind of what we're doing today. So what's the probability of throwing a dart and it lands between Q and R if it happens to hit the line between S and T? Well, how long is ST? 12, and QR is 4. So you got a 4 out of 12. Ooh, QR is 3. So you got a 3 out of 12 chance, or 1/4 of the time. You should, if you hit the line, you should be in between Q and R. Okay. All right. Area probability. Well, the probability is this area over this area when it deals with areas. So what's the probability of throwing a dart and hitting it somewhere in the shaded region? Okay, if it randomly hits there. Well, we got to find how big the shaded region is. Well, to figure out how big the shaded region is, we have to take the area of the square minus the area of the circle. What's the area of the square? 6 times 6, right?
36. I know that one.
All right, thank you, Charles. All right, the area of the circle. What's the radius of the circle? 3. So the area of the circle is pi r squared, or 9 pi. What's 36 minus 9 pi? 7.73 we'll go with. All right. So that's the area of the shaded. Now, if we're looking at probability, we have to take the area of the shaded divided by the area of the whole thing. What's the area of the whole thing? 36. So we have to take 7.73 divided by 36, which is point what? 0.215. So you got 21.5% if you happen to hit that square, that'll be in the shaded region if you're tossing darts randomly, not trying to hit it in the center. Okay? Let's look at this triangle one then. What's the area of the two triangles? Well, this is 2.5 and this is 2.5. Okay? So the area of the triangles equals 1/2 times the base, 2.5, times the height of 5. And there's 2 of them, but we'll find the area of 1 first and then multiply it. So it's like 6.25, right, for one triangle. So then, since there's 2 triangles, 2 times 6.25 would be 12.5. So the area of the shaded is 12.5. What's the area of the whole thing? 25. 12.5 divided by 25 is 0.5. You got a 50% chance of hitting it somewhere in the shaded region. Okay, 50% chance. When you're dealing with concentric circles, you have to take the area of the bigger circle minus the area of the smaller circle. And we'll do that here in just a minute. Oops. All right, so let's go here. Let's go here. And look at what problems you'll see on today's exercises. All right. So, looking at this. How big is QR? How long is QR? 2. How long is ST? Not 14. 12. 14 minus 2 is 12. So it is. You got a 1 out of 6 chance of hitting it somewhere in there. Okay? A traffic light cycles. It's 30 seconds for green, 5 seconds for red or yellow, and 15 seconds for red. How many total seconds through one whole cycle of that traffic light is there? 50 seconds. If you reach the intersection at a random time, what's the probability that it's red? Well, red is 15 seconds out of the 50 total seconds, which if we reduce it down as a fraction, 5 goes into each, 3 and 10 times. 3 out of 10. If it says write it as a fraction, write it as a fraction, not as a decimal or percent. Okay. In this figure, what's the area of the shaded region out of the total area? Well, the shaded is a sector, right? So to find the sector area, it's the angle over 360 times pi times the radius squared. So 80 over 360 is 8 over 36. 4 goes into each, 2 and 9 times. So it's 2/9 of 4 pi. What's the area of the circle? How do we find the area of a circle? Pi r squared, which is 4 pi. So you're taking 2/9 of 4 pi divided by 4 pi. There's a reason I didn't multiply through my 2/9 times 4 pi. Because what can I do with my 2 4 pi's? Cancel them. So what are we left with? 2/9, which if we round to 3 decimal places, 2 divided by 9 is 0.222. Right? Okay. You throw an arrow at the target, you hit it in the red. What's the probability of hitting it in the red? Well, we have to first find the area of the red. So it's the area of the big circle minus the area of the little circle to find the area of the red. So the area of the big circle is pi r squared. What's the radius of the big circle? 3. The area of the little circle is pi r squared, which is 2. So we take 9 pi minus 4 pi. So the area of the red is 5 pi. So to find the probability of hitting it in the red, we take the area of the red, 5 pi, divided by the area of the whole thing, which is 9 pi. What can happen to our pi's? Cancel. And so we get 0.555, but if we round to the nearest thousandth, it's 0.556. Okay? All right. ZB is in between, M and N are on ZB somewhere, and you have Z at one end, then M, then N, then B. Okay? ZM is 3, NB is 8, and the whole thing is 20. How long is MN? 9. So what's the probability of, if you throw a dart, it hits it somewhere between M and N, if it's somewhere in between B and Z? Well, that's 9 out of 20. Does that reduce? No. It just stays at 9 out of 20. Now for the most confusing one. Buses arrive at a bus stop every 18 minutes. Each bus waits 4 minutes before departing. What's the probability a person will have to wait at the bus stop at a random, that a person arriving at the bus stop has to wait more than 10 minutes for a bus to leave? Okay? Now, a bus gets there every 18 minutes and then waits 4 minutes and then leaves. Okay? So, a bus shows up. So, the time that a bus is not there is not 18 minutes because they show up every 18 minutes and they wait for 4 minutes. So, basically, a bus is not there for 14 minutes and there for 4 minutes. You get that? Because the next one comes, 18 minutes, sits there for 4, then leaves, and then 18 minutes after, the other one arrives and leaves, then another one arrives and leaves, and so on. Okay, so if you're waiting for a bus, if you're going to wait for a bus for more than 10 minutes, it's there for 4 minutes of this, so you're really not waiting here, okay? So this is 10 minutes or less for it to depart. How many minutes, if 4 minutes are spent while it's there, how many minutes there make it less than 10? If you use 4 of the 10 here, how many are left? 6 of the 10 that you're waiting less than 10. So for 6 minutes there, you're going to be waiting less than 10. And for 4 minutes here, you're waiting less than 10. So what's left up here? Well, for 8 minutes, you're waiting more than 10. For 8 minutes, you're waiting more than 10. So what's the probability that you'll have to wait more than 10 minutes? Well, for 8 minutes of the total 18 minutes, you'll have to wait more than 10 minutes. Okay? Because 8 minutes, you have to wait more than 10 minutes. These 6 minutes plus these 4 minutes, you don't have to wait more than 10 minutes. Okay? So 8 divided by 18 is what on your calculator, please? Point what? 0.4 what? 4 repeating. So 4, 4, 4. Okay? All right. And the last one. What's the probability a point will be in between 5 and 8? Well, how far is it from 5 to 8?